come to the bitwise operator. Now, what all bitwise operator we have? Bitwise AND, bitwise OR, bitwise XOR, bitwise negation, bitwise left shift, and bitwise right shift.
Right shift.
These all are the bitwise operators. Okay. Now, let's see this bitwise operator. How does it work? So, bitwise operators also follow a truth table. Why do we say bitwise operator? Because these all operators work only on bits. Now, what all bits you have? You have only two bits, 0 and 1. Only two bits, where 0 means false and 1 means true. Okay. So, you have only two bits. And now, so how the bits work? So, first of all, these operators work only on integer value. Why? Because so if you have any character, what is ASCII value? ASCII value is whatever keys you have on your keyboard that can be represented into a number, and that number is always an integer value, correct? So everything I have told in the earlier class, that everything eventually converted into the lower level language, and lower level language is what? Binary values. Okay, and binary values is what? Only 0 and 1. So when it is only 0 and 1, everything is converted into 0 and 1. To convert everything into the 0 and 1, we need only the integer value. And how you will get the integer value? So every character which you are typing, that is having a corresponding ASCII value or Unicode value, that will be represented into the binary value. Okay, fine. So these operators always work on the integers. Okay, now when it works on the integers, so all integer values are converted into bits representation, and then bit by bit operation happens. Clear? For example, let's say if you are writing, so first let's see the truth table of bitwise AND, bitwise OR, and bitwise NOR, XOR. So bitwise AND truth table. Okay, so first of all we have 1 and 1, so the result will be 1. If you have 1 and 0, then the result will be 0. If you are having 0 and 1, then also the result will be 0. And if you are writing 0 and 0, then the result is 0. So this is bitwise and truth table. Now what is bitwise OR truth table? Or, so when two bits are similar, the result will be 1. If any one bit is 1, the result will be 1. Okay, if both the bits are 0, then only result is 0. In the case of bitwise XOR operation, so bitwise XOR truth table, if both the bits are similar, then the result will be 0. If both the bits are dissimilar, then only the result will be 1. This is the bitwise and bitwise OR and bitwise XOR operators and their truth table correspondingly. Clear? Now let's come and perform this operation on the bits. For example, if you are writing 23 and 40, okay, or let's say 400, then what will be the result? How you can get the bitwise operation between them? So what I said, every value will be converted into what? Every value will be converted into a binary equivalent, right? So let's get the binary equivalent of 23. So I'll be writing print bin of 23. What will be the binary equivalent of 23? It is 10111, right? So this is the, you can write here 23 is equal to this value. Okay. Now let's find the binary equivalent of 400. Executed binary equivalent of 400 is this value, correct? So let's write it. 400 is equal to this value, right? Now see, the number of bits are not matching here. So 400 will obviously have a larger number of bits. So if you want to do this operation, the number of bits should match. Now remember, you cannot add the zeros in the end because that will change the value. So you should add the 0 in the beginning to make the same number of digits. Now it is matching. Now you want to do the bitwise AND operation, right? So this is the bitwise AND operation. Okay. This is the bitwise AND operation. So when you want to do the bitwise AND operation, in that case, let's see how it works. So in the case of bitwise AND operation, remember this table. If both the bits are 1, then only the result is 1. Otherwise, the result is 0. So here the result will be 0. This will be 0. This will be 0. This will be 0. Here only it will be 1, and rest all will be 0. So I can say 1, 2, 3, 4. 4 are zeros, then 1, and then 4 zeros, right? So basically, I can write 1 and 4 times 0. Clear? This is the result of bitwise AND operation, isn't it? Those zeros in the beginning you can easily remove. Okay, so zeros in the beginning doesn't have any significance. Now, to convert this value into the decimal equivalent, what we can write? We will be writing 0b of 0b of 1 4 times 0. This will give you the decimal equivalent of this binary value, right? So if you will be executing it, so you are getting 16. Now, are we getting 16 here? So yes, we are getting 16 here. Clear, everyone? Is it clear how this bitwise operator is working?
Yes,
Yes.
Abhishek.
Yes, Abhishek.
Now, the question is where we will be using this bitwise operator. See, as a data scientist, you are not going to use this bitwise operator at all. Why we are learning this? So the learning outcome of here is to learn these concepts. These all are the basic concepts which you should know, because there are, when you go to NumPy also, there you have bitwise operations. Okay, so you should know at least the operation or the concepts which all are the basic concepts. You may face some question in the interview or somewhere else, so at least you should have the knowledge how it works. Okay, that's it. Okay, now let's say if you are going to perform bitwise OR operation. Okay, so this is the bitwise OR sign is this one, bitwise OR. This is bitwise OR. Okay. Now, so if you want to do the bitwise OR operation, then in that case, what you'll be, how you'll be working. So bitwise OR operation, if you want to do, then in that case, if any one bit is 1, then the result is 1. Otherwise, the result is 0. So here 1, 1, 1, and this is 0. And then 1, and then 0, 0, and then double 1. So basically double 1, then double 0, right? And then 1, then 0, and then triple 1. Okay, this is what the result. Now let's find the binary equivalent, decimal equivalent of this. So you'll be writing 0b of this value. Execute it. So you are getting 407. Now if I will be writing, let's say, print 23 or 400, are we getting 407? Yes, we are getting 407. Clear, everyone? How you can do the bitwise OR operation. Similarly, let's say how we can do the bitwise OR operation. So in the bitwise OR operation, if both the bits are different, then only result will be 1. If both the bits are similar, then the result will be 0. So here 1, here 1. So basically 1, 1, then double 0, and then here also it is similar. So again double 0, and then triple 1. Clear? Now let's execute this. So if you'll be writing print 1, 2, 4, 6, 9. 1, 2, 4, 6, 9. So let's see this. 0b, double 1, 1, 2, 3, 4, triple 1. Execute this. So 391. So if we will do the bitwise XOR operation between 23 XOR 400, are we getting 391? Yes. So this is how the bitwise AND OR and XOR operators are working. I hope this is clear for everyone.
Yes.
Yes, Abhishek.
Okay. Ramesh, there is no such PDF file, but I'll be sharing these all things. You go ahead and practice it, follow the videos, you have the recording. I don't have any such PDF files or any written notes or something.
Yeah, sure, Abhishek. Okay.
Okay.
Yeah.
Okay. So now this is the bitwise AND OR and XOR operation. Now let's come to the next topic. In this we have bitwise negation operation. This is the bitwise negation operation. Now how this bitwise negation operation works? So this is the tilde sign. This is the tilde sign. Okay. Bitwise negation. Let's say if you're writing bitwise negation of a number, then the result will be minus of number plus 1. This will be the result. Clear? So let's say if you are writing bitwise negation of 10, then can anyone tell me what will be the result here?
-11.
-11. Clear? Fine. Similarly, let's say if you're writing bitwise negation of -9, then what will be the result?
10.
8.
Is it
8.
8?
-8.
Right?
Okay, yes.
-9 plus 1 -8, -8 into -8 is +8. So it is 8. Okay. Now let's say if I'll be writing bitwise negation of false, what will be the result?
True.
True.
It will be 1. Okay, -1. Clear? 0 plus 1, 1 and -1. Fine, everyone? Clear? How you are getting
Yes.
it? Okay. Now, let's see bitwise left shift and bitwise right shift. We have bitwise left shift, which is this sign, and bitwise right shift operator, which is this sign. Okay, these all are the two shift operators, left shift and right shift. Now let's see how does it work. So while doing the left shift, for that, how does it work? So these operators takes two operands. Okay, first one, the number which you want to shift, and second is the number by how many bits you want to shift. Okay, now if you'll be writing it, let's say okay, so bitwise left shift and bitwise right shift. Okay, so in this what happens, let's say if you want to shift a number, let's say I want to shift a number, do let's say I want to shift 230, shift 230 by 5 bits, to 30 by 5 bits towards left hand side. Okay, towards left hand side. Okay, so let's see how it works. So if you want to shift 230, you'll be writing 230 on the left hand side. Then left shift you want to do, you'll be writing this left shift operator. How many bits? 5 bits you want to do, you'll be writing 5 bits here. Okay, now if you'll be executing it, it will be giving you the result. But let's see how does it work. So the first step you need to do, step 1. Okay, convert 230 into binary equivalent. Okay, so the first step, first of all, let's do this. Print bin of 230 is equal to, this is the binary equivalent of 230, right? So let me write here 230 is equal to this value. Okay. Now in this step 2, what you are going to do? In this step 2, write the binary equivalent in 32 or 64-bit representation. Okay. For example, why we are writing 32 or 64-bit? That is the default, system. This one you have, right? So whether it is 32-bit or 64-bit. So accordingly, it gets stored in the memory. If it is 32-bit, then 32-bit operating system will be storing any value in the form of 32-bit. If it is 64-bit operating system, then the value will be storing it in the 64-bit information. Okay. So let's say if I am taking the smaller one, I'm taking this 32-bit. Okay. So this is how many bits you have? 1, 2, 3, 4, 5, 6, 7, 8. 8 bits we have, right? Now, so this is the 32-bit representation I'm taking. I'll be taking these are the 8 bits. This is the 4 and this is the 4. Now let's write 1, 2, 3, 4. 1, 2, 3, 4. This is the 16 and this is the 24 and this is the 32. Okay. This is the total 32-bit representation of what? 230. Correct. So you can say 230 is equal to this, right? Now you want to do step 3. You want to do left shift by 5 bits, right? So remove 5 zeros from left hand side. Okay, fine. This is the step 3 and add 5 zeros in the right hand side. Okay, so let's do that. I'll be removing 5 zeros here. So let's remove 1, 2, 3, 4 and 5. Okay, so 1, 2, 3, 4 and 5. Now add 5 zeros. 1, 2, 3, 4, 5. This is the again. Now it is a 32-bit representation of the result. Now next thing you need to do here is the step 4 is step 4. Use print 0b and 0b and the resultant bits. Okay, correct. You write it like this. Okay, means you will be writing print 0b and this one, this value. Okay, execute this, you will be getting 7360. It means you will do the 5 bits shifting towards left hand side of 230, then the result you will be getting is 7360. Is it? So let's execute this. You are getting 7360. Clear, everyone?
Yeah, yes, Abhishek. But can you tell me where we actually use this left bit operator and right bit bitwise left shift?
See, these all are done in the internal operations. Okay, so those who are working on, those who are developing kind of high-end softwares or the kind of OS and all, so they work with the bits. We are not going to use them. Even I also have not find any use. I'm into the web development, but I have not find the use of these operators a lot. Okay.
Okay.
Fine, everyone. So this is what
Abhishek,
we have. Yes.
Abhishek, when we are shifting to the left and we are considering the zeros to be shifted, is it the zeros which are going back? If the zeros at the beginning in the left side would have been 0, 1, 0, would we see it coming back from the right hand side when we are shifting it, or zeros will be added at the end?
So zeros will be added at the end, whether it is getting shifted from left side to right side, whether you do that or whether you remove it and add it here. So manually you will be removing and adding. Internally what happens, who knows? Okay, whether it is rotating in a circle or it is removing and then adding. Who knows about that? Okay.
Okay.
Fine. Now, so what is the, let's say if you want to do the right shift operation. So I'm going to do the same operation with the right shift. So in this case, what will happen now? The bits will be removed from the right hand side and added towards the left hand side. Shift out 30 by 5 bits towards right hand side. So let's see how it works. So this thing will remain same, only right shift operator will be written here. Now this is the convert 232 binary, this is the representation, this is the binary representation of 32 bits. Now this will be this value, right? So copy and paste it here and remove 5 bits from the right hand side because it is right shift. So 1, 2, 3, 4 and 5. These all are the 5 bits. Remove it and add 5 zeros in the beginning. So 1, 2, 3, 4 and 5. Okay. Now get the binary equivalent of this. So copy this and paste it here. Okay. Now let's execute it. So this is the 7. So, and if you are executing it here also you are getting 7. Clear? Now here it will be little right the binary equivalent of you. Remove 5 zeros from right hand side and add 5 zeros in the left hand side. Okay, that's it. Rest all will remain same.
Abhishek, remove 5 zeros from our right hand side or 5 bits from right hand side?
Sorry, 5 bits. There should be 5 bits. 5 bits. There are also 5 bits. And add 5 zeros in the right hand side or add 5 zeros in the left hand side. Clear?
Yes.
Okay.
Fine. This is how this bitwise operator works. I hope it is clear. Let me know if you have any question.